Assalamualaikum and hello. We are from L2A. My name is Hanif Daiman bin Hazayudi.
And my name is Muhammad Astafarhan bin Zainuddin.
Hello guys, my name is Alena Soha binti Muzammil.
And I'm Akila binti Alias. So today we are going to talk about matrices.
Ayah, do you know about matrices?
What is that?
Okay, for your information, in mathematics, a matrix is a set of numbers arranged in horizontal rows and vertical columns. The size of matrix can be defined by the number of its rows, which is m, and the number of its columns, which is n, and it's written as m by n. Typically, matrices are named with capital letters, for example, A or B, and their contents are enclosed in square brackets or parentheses.
Oh, I see. As far as I remember, matrices are essential for solving systems of linear algebra that use to organize data and solving complex mathematical problems. In engineering and physics, it helps analyze the circuits, mechanics, and robotics, while in economics and statistics, it models input-output systems, regressions, and covariance.
So, in short, matrices simplify complex problems, allow efficient computation, and serve as the foundation of linear algebra, which underpins modern science and technology. Okay, for the first question, it says that Medai owns a coffee shop called John G. Cafe. There are 3 branches of his coffee shop operating in Puncak Alam, Shah Alam, and also Setia Alam. Each branch sells 3 types of coffee. The price for the latte is 10 ringgit, hazelnut is 15 ringgit, and for the matcha is 12 ringgit per unit. The total sales in December are as the follows, which is we have latte, hazelnut and matcha for each branch, which is Puncak Alam, Shah Alam and also Setia Alam. Next, it says that the cost of production for latte is 5 ringgit, hazelnut is 10 ringgit and matcha is only 8 ringgit. Okay, let's see. First question. Express the sales data for each branch in matrix form. Okay, for the matrix form, we use 3 by 3 matrix. For the first column, for the first row, it gives us for the Puncak Alam. The second row is for Shah Alam and the third row is for Setia Alam. However, for the first column, it gives us the sales data for latte. The second row is for hazelnut and the lastly for matcha. Okay, for question B, they ask us to write the cost of production for each branch in matrix form. So we use 3 by 1 form. For the first row, it is for latte, which is 5. The second row is for hazelnut, which is 10, and the matcha is 8. So it's a very straightforward question. Next, they ask us to state the order of branch and price matrix. The order of matrix we use, which is M by N. For the branch, which is 3 by 3 matrix form, and for the price is 3 by 1 matrix form. That's all.
Following question 1D. Calculate the total profit for each branch. So we have to find the profit for each drink first, which is latte 5 ringgit, hazelnut 5 ringgit and matcha 4 ringgit, and form it into the matrix form, which is 3 times 1 matrix. And then simplify the question, which is matrix S times matrix P, and then we will got the answer. For Puncak Alam is 151, Shah Alam is 172, and Setia Alam is 160. So the total profit for each branch is Puncak Alam 151 ringgit, Shah Alam 172 ringgit, and Setia Alam 160 ringgit. Moving for the next question, If Medais want to increase sales, which coffee shop brand should be promoted more? State one reason. So in my opinion, Puncak Alam's branch should be promoted because the total profit from the shop itself are the lowest compared to other branches. And the last questions for the question 1, suggest 2 strategies that can be implemented to increase the sales of the lowest sales branch. So the first method is promote the coffee shop through social media that advertise by any influencers, and the last one is create a deal such as buy any drinks and free dessert. That's all.
So next, we proceed to the next question, which is question 2. So in these questions, it requires us to solve the problems by using mesh analysis method to determine the mesh currents. But before that, in Matrix, we actually have multiple applications that we use in our daily life. But in our task group, we chose these situations to solve problems. So, in this circuit, it shows us that this circuit is a multi-loop DC circuit, which means it has multiple voltage source here and some shared resistors and mesh currents. So, it requires us to determine the mesh currents I1, I2, and I3 for the circuit shown in the image. Alright, for the next steps, our main objectives here are to find the values of I1, I2, and I3. So, what we need to do? We assign each loops. We assign mesh current for each loops. For example, loop 1 for I1, loop 2 for I2, and loop 3 for I3. And then, for loop 1, we have V1, VR1, and VR2. By expand the equation, we can get one equation here. And then we proceed the next steps to get another 2 equation. But before that, I want to explain to you why we apply KVL here. KVL, Kirchhoff voltage law, states that the total voltage around a closed loop is equal to 0. So in this circuit, we have multiple loops. We have mesh currents and some shared resistors. By using KVL, it can help us to analyze this circuit easier, and it will lead us to get 3 equations with 3 unknowns, and then we can proceed with the next step.
So, to find the unknown, which is I1, I2, and I3, we need to convert all of our simultaneous equation into standard matrix form, which represent as AX is equal to B. So here, matrix A represent our coefficient, matrix X represent all of the unknown that we want to solve, and matrix B represent the constant that are located at the right side of the equation. So, the first important step is we need to find the value of main determinant, which this value can be found by the matrix A itself. This method can be done by using the coefficient expansion method. As shown in the calculation, we need to multiply each element at the top row of the matrix A by the determinant of the remaining 2 times 2 matrix. So, next, after we done the arithmetic calculation, we got the value of the main determinant is 43,595.8. So, for our second step, we need to calculate determinant for each variable. In this part, we need to apply Cramer's rule in order to determine specific determinant for each variable. So, in order to find delta n, we need to replace the n column of matrix A with all of the constant from matrix B. So here, as we can see, delta I1, I replace the first column of the matrix A, which is here, with all of the constant from matrix B. Then, the result from the arithmetic calculation, we got 678.6. Next, for delta I2, we need to repeat the same step, but this time, we need to replace the constant from the matrix B to the second column of matrix A, and this resulting in negative 2671.35. This is the value for delta I2. And last, for our delta I3, I replace the third column of the matrix A with the constant from matrix B. So, my answer is 2682.15. So, for our last interpretation and analysis for the value of the current, we need to use the equation which is I is equal to delta IN over delta. Delta is our main determinant. So, for I1, we need to use the formula delta I1 over delta, which the answer of I1 is 0.0156 ampere. For I2, just use the same formula, but we need to use different variable for determinant. And here, the answer for I2 is negative 0.0613 ampere. And last but not least, for I3, I got the answer which is 0.0615 ampere. We have come to the end, which is the conclusion. So, in summary, this report demonstrates how the principle of matrix can be effectively applied to solve real-world problems such as business challenges by organizing the sales figure and the cost of production. Consequently, we were able to complete complex calculation with great accuracy to find the total sales of the product.
Oh, I see. However, in electronics, matrices by Cramer's rule helps us to solve complex circuit into the easier one. They let us to arrange the current neatly, allow us to use Kirchhoff's law and solve it one by one. Okay.